Today we are going to learn chemistry and I'm going to talk about the mole. We define what is the mole. And you'll find that the mole is the SI unit for measuring substances. So when you talk of SI unit, this is a standard international unit that we use to measure the amount of substances. And we found that in chemistry, you have several substances that we can measure, right from molecules, electrons, ions, atoms, and so on. So you found that these substances, they have a number of particles. So you find that the number of particles in, for example, atoms, electrons, ions, molecules, cars or cows or people, any other thing, are measured in moles. And since we have said that moles, the SI unit of measuring amount of substances, we use it to measure the amount of particles present in these substances. So you'll find that the number of particles, we call them Avogadro's constant. So when you talk of Avogadro's constant, it means the number of particles are constant in each of these substances. And therefore, we found that this Avogadro's constant, we abbreviate as capital L. And therefore, if we talk of this Avogadro's constant, when we have 1 mole of a substance, it will have Avogadro's constant, which is equal to 0.6.023 times 10 raised to power 23. So that is when you have 1 mole of a substance. Maybe you have 1 mole of atoms, or 1 mole of electrons, 1 mole of ion, 1 mole of molecule, 1 mole of a car, 1 mole of cows, and so on. So if 1 mole is equivalent to this Avogadro's constant, which is 6.023 times 10 raised to power 23, you found that if maybe you have a lesser number of moles, for example, 0.2 moles, you want to know how much Avogadro's constant is present in 0.2 moles. You found that you take 0.2, you multiply by 6.023 times raised to about 23. If you have, for example, 2 moles, it will still be the same. So you found that you'll have 2, you multiply by 6.023 times 10 raised to power 23. So for that, you'll be able to know how much Avogadro's constant are either in 2 moles or 0.2 moles and so on. So I want us to look at another thing here known as the molar mass. Let us talk of the molar mass. And when you talk of molar mass, it means the mass of one atom. So when you're having the 1 mole, the mass of that 1 mole in grams is what you're calling the molar mass. You have 1 mole of a substance. So the total mass of 1 mole of a substance, we call it the molar mass. For example, if we talk of elements, you'll find that you want to know the molar mass of an element. It is relative to the relative atomic mass of this element. We talk of RAM. So we say molar mass will be equivalent to RAM. And RAM means relative atomic mass of that element, for example. So we are saying that the molar mass will be equivalent to the relative atomic mass of an element. For example, if we talk of sodium, and you know the RAM or relative atomic mass of sodium is 23, it means that the molar mass of this sodium will also be 23, which is the molar mass. So that is when we are talking of elements, and the example is sodium, but we can talk of potassium, we talk of magnesium, fluorine, and so on. The relative atomic masses is equivalent to molar mass of that element. So those who are elements, if we talk of a molecule, you'll find that molecule, we have what you call the relative molecular mass, RMM. So the relative molecular mass of molecule will be equivalent to the molar mass of that molecule. And for us to be able to know the relative molecular mass, we add the masses of individual atoms that are making up the molecule. For example, if you're having chlorine as a molecule, these are two chlorine atoms making one molecule. So to get the relative molecular mass of chlorine, we get the mass of one chlorine, which is 35.5. We add to 35.5 because there are two, or you multiply by 2. When you do that, you get the mass will be equivalent to 71. So this relative molecular mass, which is also equal to molar mass of that chlorine as a molecule. And we have other molecules, like we can talk of nitrogen, we can talk of oxygen, and so on. So when you talk of a compound, we have to look at now the molar mass of a compound. And a compound, talk of the relative formula mass. So the relative formula mass of a compound, we add masses of individual atoms making them compound, and that one we get the relative formula mass, which will be also equivalent to the molar mass. For example, a compound like sulfuric 6 acid, we get relative formula mass by adding the mass of hydrogen, which is 1, and hydrogen are 2, we multiply by 2. We add the mass of sulfur, which is 32, plus the mass of oxygen, which is 16. And since we have 4 oxygen, we multiply by 4. So we get the total relative formula mass. So that relative formula mass will be equivalent to molar mass of that sulfuric 6 acid, which is a compound. And we found that we are using example of sulfuric 6 acid, but you have so many compounds. Any compound you want to know the relative formula mass, which will be equal to the molar mass, you add the masses of individual atoms forming that compound.